Hello everyone, Prairie here. Thank you for joining me for the lecture today. In today's lecture, we are going to be talking about 5G technology. 5G technology. So 5G is something that has come a lot in the news recently. So you might have heard about it. There's a lot being talked about 5G technology. But as a technologist, you might be wondering, what exactly is 5G technology? What does it mean for you, for your career? Or you're just curious, you just want to stay up to date with 5G technology? And a few questions that we might ask around it. What is it? What do I need to do? Why is it coming now? When is it coming? Why is it relevant? Will I need a new phone? Will it work in rural areas? What are the promises and the concerns? So there are a lot of questions we're gonna ask and answer around 5G technology, and the whole goal for this exercise is to break it down, the key concepts that exist within 5G technology, so we can have some understanding about what it is. But before I go too further into this, I just want to say this is not my area of expertise. I don't claim to be a communication expert. I'm a software engineer, a sales engineer, but I pay specific attention to this just because it's very relevant and might have impact to not just individuals who are engineers in their career, but for the way we communicate in general. So this is something that's very important. With that said, for those of you that might be experts as I go through this, if I miss something, be sure to leave it in the comment below, and I might have to do some corrections to this video. But I think I've done a pretty good job of the research that has been done. So I'm going to be looking at my notebook and referencing this just because a lot of the concepts are very new, and I want to make sure that we don't miss anything as we go through the exercise. So let's start with the lecture. What exactly is 5G technology? And why is it relevant today? Why is it especially relevant? So to dive, what is 5G technology? Let's take a look back down history and memory lane. Where have we been from a communication perspective? So let's say we have two people, and I'll use a red dot here. So Mary, this is a cell tower, and it has an antenna. And then we have Mary or John sitting here. When John wants to talk from a communication perspective, John picks up the phone, and let's say there is another person here, Peter, and Peter dials the number. Some waves go over to the antenna, and the antenna relays those waves over, and Mary or Peter or Alex or whoever is here can pick up the phone and they can communicate. Right, you can stack a bunch of antennas in between them and they can communicate. So this wave that is sent over is really going to be at the heart of what we talk about when we explain 5G technology. So this wave would be at the center of that. Now I'm going to wipe this out. We have a basic idea of communication, right? So going down memory lane, what have we seen? We've seen 1G, 2G, 3G, 4G, and now 5G that we're going to talk about. Just for a refresher, we'll make sure that we're all going. So 1G, 2G, 3G, 4G, 5G. Guys, that's where we've been. So what did 1G allow us to do? The wave that we saw earlier. 1G allowed us to, this was the first time where phones really became a thing, right? Before you needed landlines to connect. If I wanted to stay from my house and connect to in Boston and connect to somebody in New York, this house needed to be physically connected to the house in Boston by a landline, right? So that's how communications and phones existed. So physical landline connections. And then we saw how I drew just a little bit earlier where everything now becomes a wave. You pick up your phone, and instead of this landline here, we have some antennas here, and now we're dealing with waves. So you pick up your phone here. So you pick up your phone, and now waves are going there. The antenna relays those waves over to this person, and then they can talk. No need for physical antennas. No need for physical cables. All right, so that is what we had before. Antenna, we had cables, and then we switched to doing waves. So 1G was the first generation of the wave that was being sent, and it allows us to have cellular phone calls or cellular networks and was able to, instead of using a landline, we were able to pick up a phone and call somebody. So that's what 1G allowed us to do. I'll do that in green. Cellular. So you can pick up a phone and you're talking to somebody, and you can walk around the house and you're walking around the neighborhood, and you're not worried that you're tied to a landline, and people became a lot more mobile. So the beginning of the mobile network, right? So that's really the birth of the mobile network, 1G. Now, things advanced. This was when the first phones were coming out. Those phones were very bulky, right? I don't think I was born in that time, but I know those phones were very bulky at the time. I've seen a couple of them in old movies and things like that. Now, advances continued, and then we had 2G. 2G, what did this allow us to do? It allowed us to do things like texting or SM or sending text messages, SMS. And that was a big deal, because in the old phones of cellular, of 1G, you couldn't send text messages at all. Now with 2G, people were able to send text messages, and it was really great. It was a big deal of being able to send text message, and not just can you walk around and talk, you can actually text message people. 3G came out with a lot more advances, and I'm not putting the date range here where they came out. You can think about 2G being in like the 1990s to like say 2000 or 2003, 2004. So I might be wrong with those dates, but then that's 2G, and then 3G came out, allowed us to send pictures and videos, right? So this is some of your mobile phones that allowed us to send pictures and videos. With 3G we were able to do that, but it was slow. This was like when you send a picture and somebody will be angry because it takes a long time to send a picture and things were slow. You wouldn't even think about going on YouTube. YouTube was just kind of coming out at this time, but if you go there and you're watching a video, it just takes forever to download and to install on your machine. So, but that's what 3G gave us, and it was a very fascinating time. Then around, let's say 2007, 8, 9, 10 into where we currently are, we had 4G. 4G brought us speed, again with videos and like your web 3.0. This was web 2.0. Web 3.0, where everything was fast. You can, phones now are just blazingly fast, right? I can go on YouTube, I'm watching videos. You might be watching this video right now on your YouTube phone or your mobile phone. All that data is happening. The lag might still be there, but not that much. It's not that annoying the way it used to be back in the 3G day, where you download something on LimeWire or wherever you download something and you have to wait forever for that to happen. So 4G brought us a lot of speed, and 4G has had several evolutions. So 4G has had several evolutions, and one of them being, and I'll do that in a different color, one of them being the LTE, right? So it was not just 4G. Now you have the LTE, long-term evolution, that brought more speed, right? So you might have 4G LTE on your mobile carrier, and it's really amazing what this has brought us. So this is where we've been, and now we are in the point where people are talking about 5G. Everyone is talking about it in the news. You're hearing China is making advances in 5G. Everybody's really talking about 5G. So what exactly is 5G, and why should you care, and why do we need it now? Right. So what exactly is 5G, and why should you care? Why do we need it now? So I hope this is answering that question of what is 5G. 5G is just a continuation or an evolution. Well, I wouldn't even say an evolution. I might say a revolution, because things are really going to change. When we came down here, we were kind of evolving and increasing speed and things like that. But 5G, it's not just evolving and giving new capabilities. It's kind of promising to really be an evolution of how we use mobile network for communication in terms of the speed that it can offer. We're talking about 100 times the speed. Evolution to me is like you a 20% improvement. So we're talking about 20% improvement, like from there to like a 100x improvement. That's different. When you improve something by 20%, it's minor, it's minute. When you're talking about going 10x, 20x, 100x, speed in terms of what 5G can deliver, then we know we're looking at the revolution, not just an evolution. And so that's something to really keep at the back of your mind, that 5G is really promising to change the game, the way things work. Now, how is it promising to do that? I am going to, let's do this, guys. I am going to draw the diagram here for an antenna, right? And let's say this is an antenna, this is a person. So antenna, person. The way they want to talk, they send waves. Before I was doing my wave that in the conventional way of doing wave, but let's do it as a wave is literally, that's what a wave looks like, right? You're up and you're down. That's a wave. You're ups and you're downs. So this is what is used to send information from this person to this person. Now, waves have these two critical properties: frequency and amplitude. So to break it down, wave have frequency. Frequency means how many waves, this up and down, do we have. So this is the frequency. If I do more like this, this is higher frequency, lower frequency. So depending on the frequency that you choose, you can use that wave to send information, right? So let me cancel that and redraw it again so we can hopefully get it. So now just imagine this. So this is a wave. I'm gonna draw a wave with different frequencies. All right, so here I'm in my high frequency. Sorry, that's not high, that's low frequency. Gotta be correct with that. So here I'm in low frequency, and here I'm in high frequency, right? So this is by frequency. Now, the way we send information is you have to pick a frequency to wish to send that information. So you cannot just send information and decide what frequency you want randomly. So most organizations or most governments have dedicated to say, well, for texting and mobile communications and all that, we'll allocate this band of frequency to you guys to use. So they give it to companies. They can say, for those in the US, they can say, Verizon, this is the band of frequency you can use so that you can send information from your antennas to people, right? And so they can allocate, they can come in now and allocate this band of frequency, let's say from here to here. And so this band of frequency is used for cellular network. Okay, guys, I hope we're getting this. So this band of frequency has been allocated for cellular networks. And that's what we've had all along in this conversation, where a particular band of frequency was allocated for cellular network communication, and then we just simply evolved by trying to optimize and get the most out of this band of communication of frequencies. I mentioned wave has two properties, frequency and amplitude. I'm not going to get into amplitude now. Amplitude, that's where you hear frequency modulation, FM, amplitude modulation, AM, right? So there's a lot that you can go into that direction, but here we'll just focus on the frequency modulation, which means that you send data across different frequencies. So if you've ever looked at your radio, I'm like, why do I have AM here versus FM? That's why. With frequency modulation, which is what we're focused on here, is you are sending data by depending on the frequency that you're using. With amplitude, you're sending data based on how high or low. Amplitude is the height between your lower crest here to your upper crest, right? So this gap here becomes your amplitude. So the higher that is, higher amplitude. The smaller this, that's smaller amplitude. Amplitude. But that's not what we're talking about here now. Let's just focus on this band that has been allocated to cellular networks. So I'm sure you're wondering, what exactly is that band that has been allocated to cellular networks? I want to make sure that I get the exact number down here. Is that number goes from, and I'll make sure that I write it. It goes from about less than 6 gigahertz all the way to like 3 kilohertz, right? So right now, 6 gigahertz to 3 kilohertz, that's the band that is currently available for cellular communications, for companies to use in cellular communication. That's the band that's currently available for that. All right, guys. Now, I'm sure you're asking, but why is that important? Why do you have to tell me what the lower end of the band and the higher end of the band, right? And that's such a small number. What about all of this? What about all of these bands that are here, right? As you go to higher frequencies, and you can go all the way to the end of the screen that way, right? What is happening to those bands? Why are we not using those, guys? And that's really where 5G comes into play. And that's why I say 5G is more of a revolution than an evolution, because in the past we're just trying to cram as much data into these frequencies, right? But with the revolution, we're saying let's expand the frequencies. So 5G is saying that instead of just using these frequencies, we're going to take advantage of all the frequencies here that are not being used to send information, right? And so these frequencies that are here that are not being used, you can call them EHF, extremely high frequencies. So these are higher level frequencies, because remember, as we're going, the more of the up and downs that you have, the higher your frequency. So this higher frequency is what is being opened for us to use in 5G technology. And you can imagine, like, you have two highways. You have a highway, and the government said, well, you can only use one lane. And then it becomes so congested, and the government says, well, instead of one lane, let's use 4 lanes. So now you have 4 lanes to use in that highway. So think about this frequency range as the highway. Now we have a whole new set of range of frequencies to use to move information, right? And so just guess how much information we can send now with 5G, because this has been open. So that is one of the things that is really making 5G very powerful, because it's a new set of wave of range has been opened for us to take advantage of. Okay, now going to point number 2. I'm going to cancel this. I hope this is clear now. I'm going to make sure we cancel this. All right, I want to stay on this topic. What exactly is 5G, and dive into a couple of other things to explain some of the technologies that are happening there. One of the things that I mentioned was, well, a whole new spectrum of wave spectrum has been open to use for communication, for sending information. Sure, but do we just use it? Are there any challenges? Why are people making such a big fuss about it, right? If it's just using spectrums, we already know how to use it. So why is it such a big deal? Is any innovation happening in that regard? Guys, if you're wondering about that, then you have been thinking correct, because a lot of innovation has been happening. And that's why people are saying 5G is not going to come out till like 2020. And I'm going to talk about when is it coming here in the next point. So the innovations that are happening there, and I'm going to write this down, falls across a couple of properties. So number 1, we have the millimeter waves, and I'll explain what each of this means and why it's important. Number 2, we have small cell networks, right? Number 3, we have, which one do we go for number 3? Mimos. All right, so we have the Mimos, and then what do we have after that? We have number 4, which is your beam forming. And then number 5, we have full duplex. So these are some of the innovations that are coming in. And guys, before I go any further into this, I really want to explain that the innovation in this space is still happening, right? All these concepts are just things that people are working on in research. They're trying to bring it to industry. So there's a lot of innovation that's happening here, and the dust hasn't settled yet. That's why 5G is not something that you can just walk down to your store right now and get it, because these things haven't been implemented fully yet. And maybe some new technologies out there that I'm not aware of, or some of these things might not even make sense. Maybe they cannot implement beamforming in the industry the way it's been done in the lab, and so this might just go away. So that's why I really want to caution us that a lot of this technology, it doesn't mean that they exist already in the industry. Now, let's break it down and explain why each of this is relevant into understanding what 5G is. Millimeter waves. It just goes into the diagram I drew a little bit before, right? Like I said, you have one antenna here. You're trying to send data to another antenna that's here, right? And now, instead of using long waves, which is just one spectrum, now we're using the millimeter waves, which is the smaller waveforms, which is the lower end of the spectrum that I did a little bit earlier, to send that data. So we're using millimeter waves. This is what we'll call the millimeter waves. So one of the technology that's happening, or the shift, is going away from using just that spectrum that was provided before, which is about 30 gigahertz, less than 6 gigahertz, to about 3 kilohertz. Let me write it down. So I think here it was like 6 gigahertz to like 3 kilohertz. Also, I want to make sure that I get that right. Yes, 6 gigahertz to 3 kilohertz. Instead of using just the spectrum, we can start taking advantage of the subpolar spectrum, this millimeter waves, which is like supposed to be higher frequencies. So we're talking about 30 gigahertz to about 100 gigahertz or 300 gigahertz. So this is your higher frequencies. Now, so this millimeter wave is really the innovation that's happening around taking advantage of this smaller wave. But waves have this problem, which is, it's just a characteristic of wave. If you have a wave with, like this one below here, right? This wave here, it has a lower frequency. This is a lower frequency wave. This is a high frequency wave. So let me actually write it here. So low, high. So these lower frequency waves, waves with low frequencies, they can travel very long distances. So we're talking about your radio wave and things like that. They can travel really, really long distances. And waves with these high millimeter waves with high frequencies, they don't travel a lot of long distances. So we're talking on the lower end of the spectrum, all the way to like microwaves and things like that. They don't travel very high, or they don't travel very long distances. So why am I explaining that? Because if you walk around town, your area where you have cellular network, you don't see antennas everywhere, right? Because it might be annoying to people if every electric pole you saw was an antenna. That would be too much. Because waves have these characteristics of going long distances, the city can afford to put one antenna here and then go a long distance, right? And then put another antenna. So the city can afford to do this in the old approach. But guys, what I'm saying now is, this is what we used to do, and now they're talking about coming to these high frequency waves, right? Your millimeter waves. Your millimeter waves have this characteristic that they cannot travel this long distance. By the time they reach there, they're done, right? Too much energy, then the wave is done. So if I was to sit here and send information here, how would I do it? Because it doesn't go as far as the low frequency waves go. High frequency waves just go very short distances. So that's where the next thing comes into play, which is the idea of small cell networks. Because now, instead of having two antennas that have long distances apart and they can send information, so that if you're standing by this antenna, you can answer your call. If you're standing here, you can answer your call. Now we need a lot more antennas, and I'm going to do that in green. So you need one antenna here, smaller antenna. You need one here, right? You need another one here. You need another one here, and then another one here also. So now this antenna will send to this one, it sends to this one, it sends to this one, it sends to this one, and now you can see this as being the network. Let me write this correctly. Your network. Guys, bear with me. I want to make sure that I write that out on the board so that everybody can read it. So it goes to your network. So this is your small cell networks, right? So you have smaller cells of antennas that beam very short distances, and it forms a network, and that's how it's able to take advantage of this new millimeter waves that are coming online, right? So I hope this makes sense, guys. I hope this is all making sense as we're breaking this down and going from A to B, to number 2 to number C. So we're seeing now the small cell networks are coming into place. And I'll talk about this once we get to point number 6 here of some of the concerns that people have is, well, I don't want to be seeing all these networks around my neighborhood, or what's the impact of this? Does it mean we cannot take advantage of this existing infrastructure? We need to put out new infrastructure. So that's really one of the challenges that you will start seeing when we talk about 5G, because unlike going from 1G to 2G to 3G to 4G, where it was just a matter of taking advantage of these two towers and just optimizing it, 5G is telling us now that we might have to build new infrastructure and put all these cell towers. So just imagine the cost to go across the entire United States or whatever country you are and implement new infrastructure like that. That's why 5G seems to be taking along and people are talking about it, because it's really going to have a lot of impact and it's not cheap. All right, now we'll go into the next point number 3. What is the Mimo? Mimo stands for multiple inputs and multiple outputs. That's what Mimo stands for. So multiple inputs and multiple outputs. And why is that relevant? It's relevant because if you look at this antenna here, this antenna, it could only have a certain amount of, let me just draw this as rings on top, amount of input. Think about, like, let me describe this in a better way. Think about like you go into a city and you're trying to an event and you need to park your car, and you go into a parking lot. The parking lot has maybe 20 parking spots. So in order for you to park your car, there must be a spot for you to park your car. And then if it's full, you have to wait for someone to leave before you park your car. That's the capacity. So let's just use that example here. So what will happen is these antennas would have a certain amount of inputs that they can use for sending data. So let's say this has 10, this has 10, right? So if I'm trying to call, it would take one of these inputs and be able to transmit my data over. Now I have 9 remaining, right? And then if another person comes online, it takes it, and then 8 remaining. So if you have, say, 12 people here that are waiting to make calls, well, there's just 10 inputs and outputs here. So 2 people are gonna be sitting on the line and waiting for there to be a spot for this to be able to send their wave or their information over, and for that to come online. So that could really be a challenge, and that's why sometimes you go around, you're calling, the call drops, and calls drop for different reasons. But that could be one of the reasons why, because this has a fixed capacity just of about 10. But with Mimo, multiple inputs and multiple outputs, this allows these antennas that are here, and the antennas in green are 5G antennas. This is 4G, this is 5G. So these 5G antennas have way more inputs. We're talking about 10x the input. So here there are 10, we're talking about 100 Mimos, input output. So you can cram in more information, more input and output to send that information down the line. All right, I'm gonna keep going on so that we can cover some of the other things here as well. Yeah, beamforming, right? Beamforming is just a way of and beamforming and full duplex kind of are kind of similar technologies that should work together. Well, beamforming allows you to be able to direct the wave, to direct the signal that's coming from an antenna into a particular direction so you can optimize it for more efficiency. Let me explain. And to explain that, guys, I'm going to have to cancel this out. So guys, on to beamforming. Beamforming is another technology, innovation within 5G that allows us to be able to focus beams of information into a particular direction without wasting energy. So let me actually draw the diagram of how your typical 4G and previous generation antennas would work. So you have your, let's say, 2 antennas, and they're trying to send information, and there's somebody here. Let's draw that well. And there's your person standing here, and they're trying to make a call. So what this antenna does is it just beams out information in all directions, right? This antenna is beaming out information. Let's do that in a different color. Why don't we do that in a different color? So this is beaming information out in different directions, and you can imagine multiple antennas beaming out information in different directions. There are a lot of problems, right? Number one, you're getting a lot of interference and just confusion for the information coming to this person, and so there's a lot of challenges with this, right? What beamforming does is this antenna can sense that this individual is standing here, and instead of wasting energy sending all this wave in directions that no one is consuming, it can actually send a focus beam to that person once it senses where the data is being consumed. So that's really what beamforming does. It's a technology that allows this network to be able to focus beams to a particular individual, right? So that, you know, all the wave coming this way is not being wasted. So that's one technology about beamforming. There's a lot more into that, but I think that this gives you an idea of what beamforming does. And the next thing that we want to talk about, guys, is full duplex. So number 5, which we'll hear now, is full duplex. So what does full duplex do for us? What does it achieve for us? So if you think about the typical network, you have 2 antennas here. Again, we're talking about one antenna, another antenna here, and they're trying to send information. So this guy is sending out the wave, right? So if you think about this wave as being a highway, the current technology, you can only send data in one direction on that highway. If somebody is coming on the other side on this frequency, you have to wait when these are sent and then you receive. There's a lot of inefficiency sitting and waiting for that information to go across. What if you can optimize that and send data in different directions on the same frequency, the same wavelength, without interfering or affecting the other one? So this person is sending, this antenna is sending that way, this is sending that way on the same channel, and there is no interference. There is a lot of innovation that's happening here to make this possible. The concept of switches, and it really gets a little bit complicated, that allows them to sense data coming from this way and switch them into the correct channels real time. It's amazing. But just from a concept of what the full duplex does is it allows this antenna A to be able to send data to antenna B and vice versa, all happening at the same time. So guys, there you have it. We've gone through a couple of the important technologies and the innovations that are happening to make 5G possible. And just to recap, millimeter waves, small cell networks, Mimo, right? Multiple input and output, beamforming, right? We've just talked about that, and full duplex. All right. So this is all for those that don't care about the technology itself. We're going to be answering a lot of other questions in terms of what does it mean for you as the average user. I know some people care about the technology, not everybody does. So I want to make sure that we answer questions for everybody. So we're going to go in now to the next part of this lecture, which is the pieces that are not as technical as these technologies we've gone through. So guys, what is the first piece? What is 5G? I hope you understand what 5G is. The new innovation, the new technology that allows a lot of data to be sent online using different spectrums of data, you know, greater than 30 gigahertz to about 300 gigahertz from a technical speak. Why do we need it? Why is it the time now that we need 5G? Okay, so in my previous video, I talked about IoT. Guys, if you haven't watched that video, I would recommend go to my channel, look around. You'll see a video where I talked about IoT and why it's relevant. But the use cases that allows, or that is pressing the need for 5G goes around. We have virtual reality, right? We have self-driving cars, right? Drones. Of course, we've talked about IoT, the Internet of Things. That's all coming online. And there's just a lot of things that are coming in, just even robotics, agriculture and automation that's happening there, right? So a lot of these devices are all coming online, especially IoT, your refrigerator, your watch, your TV, your lawnmower, everything around is being connected to the internet. Now, if you've ever been in a situation where you have a party and a lot of people come to your house, or you go to a party or an event, and with a lot of people around, and you start realizing that you're having issues with your network, what's happening? It's because the bandwidth is being stretched. When you have a lot of people online trying to consume data at the same time, there's problems. So how do we solve that problem in the current situation where instead of just having 5 people or 10 people or 100 people, we're talking about millions or billions of devices that are coming online and they have to connect to the internet. The current infrastructure and the bandwidth will not scale, will not keep up, which is why 5G is really becoming a big thing to help IoT and virtual reality. With virtual reality, you're thinking about real life scenarios where you're doing virtual reality stuff. That takes a lot of data. Gaming and all that stuff takes a lot of data, and so there is need for the speed to allow for all of that to happen. There are other use cases here that we can talk about, right? But I think that we get a sense in terms of with all these devices coming online, that is why we need 5G, and that's why 5G is really becoming a big thing in the industry. Now we're gonna go ahead to the next piece here. I think we've answered the question of why do we need it, guys? Because of IoT and a lot of devices are coming online. People want speed. Speed is important these days, guys. I'm hearing statistics of being able to download a high definition movie, like one HD movie in minutes or even sometimes seconds. That's unbelievable, guys. If you think about downloading an HD movie now, it takes hours, right? Sometimes you have to go and see it and wait with the best networks that we have, right? Current speeds go up to what? About 40 MPS, megabits per second. Current speeds. We're talking about 100 times this, or so 10x to 100x this current speed. So take what we have right now, and this is not 100% improvement. No, there's a difference. This is 100 times. There's a difference between increasing something by 100% and taking something by 100 times. So if you have 2, let's say our current speed is 2, 100% means I'm going to 4, right? I've increased it by 100%. When we go by 100 times that, so I'm going from 2 to 200. This is a big difference. From 2 to 4, 100% improvement. From 2 to 200 is 100 times. So there is a big difference. So when we hear 5G and we're saying that it comes with 100x the speed, or 10x or 20x or whatever it is, we don't know yet, right? The dust is going to settle and we'll get exact numbers. But the numbers are just staggering. If we take the extreme of 100x, that is a lot, guys. Going from 2 to 4 is 100%. So we're making things 100% better. We're talking about 100 times. So we're going from 2 times 100 is 200. So the promise is just amazing, and that's why we need it. All right. So the next part of this lecture, we're going to be answering this question: when is it coming? No one really knows. I don't know, and I think very few people know. We know China is saying that they want to get it into production, into the real world, and implemented by let's say 2020. Some say 2019. I don't think they have it, right? But a lot of companies are saying they want to get it in by 2025. You might hear people saying they want to get it in by 2022. So there's still a spectrum there. So it's not something that, especially for those in the US, where you can just walk down to your store and get it yet. So, but it's coming. China is really doing a lot of innovation around this and leading the way. But the timeline is very fluid. But it's not. This is what 2019 we're making this video. So we're talking about late 2019, what China is promising, to 2020. But a lot of nations are just not there yet, right? So when is it coming? I think we've answered that. Now we go into the next question. Will I need a new phone? Probably. Probably. So the answer to that is probably a yes. Guys, when we had going from say 2G, 1G to 2G to 3G and 3G to 4G, some people were able to get away with it without needing new phones, right? Because a lot of it was just optimization and not necessarily changing hardware. But as you can see from the previous part of this video, there's new hardware in terms of the new antennas, right? That needs to be all put up. We talked about it, that allows beamforming, the antennas that can support millimeter waves and things like that, right? And then phones that can even pick up those frequencies, because who knows whether the current phones can pick it up. I know Samsung for sure is talking about coming out with the S10 5G sometime in 2020, I believe. But companies I don't know if it's out now already, but you can check it out. That's something that the companies are already working on it. So more than likely there might be a need for a new phone because the technology is so new and radical that new hardware will be required. All right, now we go to the next piece. Will it work in rural areas? And this is one of the challenges. If you travel a lot and you're walking around a lot, you're not in the cities, right? We know in the cities you get the best connectivity. Now once you start traveling and driving across America or driving across London or England, right, you might go into rural areas, and the question is, we know rural areas already struggle with network connectivity. Would this solve the problem there? Not necessarily, at least for the start, just given the fact that 4G already, which has been in existence for almost a decade now or more, still has problems, hasn't penetrated to go to some of the rural areas because antennas just haven't been put up there yet, right? And so companies are still scrambling to put that in, and then not to talk about getting it up to speed with like LTE, right? So in rural areas, that's still coming up. Now talk about putting all your new millimeter wave supported antennas and be able to do all of that in the rural area. So eventually, I believe in technology that people in the rural areas deserve to get good connectivity too, but it just might take a longer time than what you get if you were living in a city like New York or Boston or London, because it's easier to deploy to those areas quicker than it is to do it in the rural areas. So will it work in the rural areas? The answer to that is, of course, yes. It just might take time. If you're, say, in New York or Chicago or some of the bigger cities, yes, it's easier to deploy them. Once it rolls out, those areas might get it first. Okay, promises and the concerns. So guys, we've talked a lot about this. I've gone through explaining the technology and giving some terms: full duplex, massive MIMOs, small millimeter wave, small cell networks, beamforming, millimeter waves. There's a lot of technology that's happening there, right? And we've seen a lot of the use cases with IoT, with self-driving cars and drones, and just people want connectivity fast, and a lot of devices are coming online. That has a lot of benefits and that's a lot of promise. But are there any concerns to this? And to be honest, I want to make this video not just a video about hyping up and talking about how great this thing is and the promise and what the future will hold, because the future is definitely looking bright for this technology and the benefits that it can deliver from a connectivity perspective. But as people in the industry, you always have to look at the good, the pros and the cons. I'll be doing a disservice if I talk about all the pros and not talk about being critical too of the cons that people have mentioned out there. So some of the things that you hear about it is around the millimeter wave. So when I drew the diagram, I talked about, you have your antennas, right? Now, instead of sending long waves, they're sending these millimeter waves, right? These are smaller millimeter waves. So in wave, normally you would have like your radio waves over here. These are high frequencies, and then the low frequencies would be like your millimeter waves. Microwaves would tend to be on the smaller side. Microwaves, right? So if you think about it, currently what we do now is higher frequencies around, on this higher end of the spectrum. These low frequency waves that can go long distances don't need a lot of energy. These smaller frequency waves, which we're talking here about, like your millimeter waves, need a lot of energy for it to go. So first, people don't want to have all these small antennas all over the city. So think about a city that might have 10 antennas or 20 antennas now to support it. And you're saying, well, let's replace this with about 100 or so smaller antennas, right? And is that going to affect the skyline? Do people want that around their houses? There's a lot of concern around that. The next piece is, well, now you have those antennas. Not only do you have it by your house or in more locations now, these antennas are consuming more energy to send very high frequency waves. So energy consumption is a lot, and you're having high frequency waves all over the place because it's carrying a lot of information. But the body also takes some of those waves, right? That's why you wouldn't take your hand and put in the microwave and turn it on, right? Because that would not be that wouldn't end very well. If you can take your hand and put in the microwave, that would not be good, right? It literally doesn't do very well in there. So now no one is saying that these are microwaves, right? Of course, this is not on the level of microwaves, but still, what is the impact of that on the human body? Is it fully understood, right? And some people have concerns about that it might have effects on the body and no one really knows. So those are some of the concerns that you might hear people bringing up with this, with 5G. But I hope that this overview is a little bit of a longer video, a longer lecture, gives us not just one side of the discussion. I really wanted to talk about what it is and some of the technologies that are happening in there, which we went through, why we need it and when it's coming, and do you need a new phone? Because some people don't care about all the technology, right? They care about how is it going to impact me with my phone, right? I haven't even gotten into my phone bill go up, right? People might be worried about that. So those are things to also pay attention to. What does it mean for my profession as a technology professional? Like, is everything going to be the same? Will people start working from home now because there's so much connectivity, and remote work will not become what people will be doing because there's just so much connectivity? Those are things to really think about, right? What does it mean when you can stream, one HD movie in minutes, right? There's just a lot of things that can happen from that perspective. New businesses can come out that people haven't even thought about yet. And so that's really one of the things that's really exciting about this is we know that technology usually comes, and people know what it is, but what people usually miss is they don't know what the potential it is until it comes into existence, right? Like Facebook and Google and YouTube, those technologies did not really take off until we had that second generation of going from 2G to 3G that allowed mobile phones to really take off, and people started becoming more, consuming more data and going on Facebook a lot and spending a lot of time there. For example, in Africa, a lot of people don't even have landlines connected. Everything is mobile, right? And people would just use mobile phones and do mobile payment, and everything is mobile communication. And as we're thinking, what would this even mean for like the third world countries as well, in terms of the development trajectories that happen there, right? So those are some of the things that people are still trying to figure out with this 5G technology. China is trying to run with it and lead and really take advantage of it. You hear in the news how Huawei, I can't really pronounce that correctly, is producing a lot of equipment that can do all this talking around. And so, US wants to take lead in that, and there's just a lot of discussions going around. But as a professional, it's very important just to be aware of what's going on in the industry and what that might mean for you, for your job and your career, right? Then last but not least, we talked about the pros and the cons. What do people think about it? What the people who support it, what do they say? People who don't support it, what are the arguments against it? So guys, I hope this helped and gave us a quick summary of want to make sure that we covered all the important points here in this lecture. I think we did. If there's anything, guys, any questions or something that I did not cover, be sure to leave it in the discussion below. Are you excited about 5G? Does this help you? Do you have any concerns? I really want to hear what you guys have to say. And I'll see you in the next lecture. Thanks for watching.